Hello, we're back again, and we're going to be talking about the absolute extreme of a function. Now, in class, we talked about the local extreme, or should we say the relative extremes. And of course, you have the minimum points and the maximum points on both relative extrema and also on the absolute extremes. Now, when we're talking about finding relative extremas, we basically are talking about the first derivative test. And also, of course, we'll get more involved with second derivative tests and that sort of thing with relative extremas at a later date. But we'll be talking about absolute extremas tonight. And absolute extremas is when we find the critical numbers of f that lie in the interval of a, b. We compute the value of f at each critical number found in step 1 and compute f of a and f of b. And the absolute maximum value and the absolute minimum value of f will correspond to the largest and smallest numbers respectively found in step 2. Now, let's look at an example. I also want to say that the extremas, absolute extremas, also deal with the optimization, and we'll be talking about the optimization of problems dealing with observation 1 and observation 2 of the absolute extremes. So we want to find the absolute extrema of the function f of x is equal to x squared. And it's defined on the interval of what, -1 and 2. And as you see, it's a closed interval there, right? So these numbers here will also be inclusive in our calculations, as you'll see in just a second. So we see that we take the derivative of x squared, which is 2x, and we're going to set f prime of x, the derivative of f of x, set it equal to 0. And when we do that, we solve for x. And we come up with 0. So 0 will lie within, it lies within the interval. So we can use that. So when we use this to calculate the absolute extremas, we want to plug it back into the original function. So f of -1 is going to be what? +1. And with f of 0, will be what? Equal to what? 0. And as we take 2, we'll substitute that into the original function, and we will get the answer 4. So we can conclude that for this problem, that the absolute minimum here is 0, and also the maximum will be what? 4. So 4. So that's how you do this particular problem. Now, sometimes when you're solving these problems, sometimes when you find critical points, they may not lie within the interval, if you will. They may not lie within the interval. It's a little bit late. So if it doesn't lie within the interval, we have to not consider that critical number, that value in the problem. We'll totally drop that particular value from consideration of the problem, which you're getting ready to see right now. So we want to find the absolute extrema of the function f of x is equal to x to the third minus 2x squared minus 4x plus 4. Defined on the interval 0, 3. Of course, again, these are brackets, so that means that this is a closed interval, and these numbers are inclusive in the calculation for the absolute extreme. So we find the first derivative, which is 3x squared minus 4x minus 4, right? Of course, as you see the original function, x to the third minus 2x squared minus 4x plus 4. Its derivative will be 3x squared minus 4x minus 4. So we set f prime of x equal to 0. So in this case, we have to factor this function, or should I say the derivative of the function. And when we set this equal to 0, we come up with 3x plus 2 times x minus 2. And we set that equal to 0 because we factor that. These are the factors of this. So now we're going to solve for x. And when we solve for x, we come up with x is equal to negative 2/3, and then x is equal to 2. So now, here's what I was talking about earlier. X is equal to negative 2/3 is not within the interval guidelines of this interval here. It's 0 and just 3. So that's below 0. So 2/3 is not within the interval. So it will be dropped from consideration of this problem. So we'll continue on using this critical point, which is x is equal to 2. And we'll use this. We'll say 0. We'll use 2, and we'll also use what? 3 in this case for the calculation of the absolute minimum and maximum. So when we plug in f of 0, we get f of 0 is equal to 4. When we substitute in f of 2 into the original function now, we're going to get negative 4. And then when we substitute in 3 into the original function, we're going to get 1. So we will have now the absolute minimum here will be negative 4, and the absolute maximum of this function will be what? Positive 4. So this concludes our video on absolute extremas. Stay tuned for videos later on in the future for the professor, Daniel Fritz Mathematics.